Hi, this is Sanjay Gangal from EDACafe. I'm here with John Coonrod and Mahyar Vahabzadeh from Rogers Corporation. Hello, John and Mahyar.
Hello, Sanjay. How are you?
Hey, Sanjay. How are you?
Doing great. So tell us about Rogers Corporation.
Sure. Let me just start off to say that it is a company with a lot of history, and we're very proud of that. So we're actually one of the oldest companies incorporated in the U.S. We were incorporated in 1832. And over that period of time, we've done a variety of things, of course. And mostly, I would say we've been a specialty material supplier. And for the division that Mahyar and I are representing today, it's really materials that are supplied into the printed circuit board industry and also the printed wiring board industry. And typically what we're doing is supplying specialty materials that are used in high frequency applications or high speed digital applications. And we actually serve quite a variety of industries that use that kind of technology, of course. So we're involved with aerospace and defense and wireless infrastructure, high-speed digital, automotive. Those are probably our key markets, but there are quite a diversity even within each of them, such as aerospace and defense. There's a huge amount of different applications there that we support.
And where are you based at?
Oh, yes, we're based in Chandler, Arizona. And as part of our history, we're based in Rogers, Connecticut, but it just made sense over the years to go ahead and move out here to Arizona, where a lot of our bigger divisions are located.
Okay, but otherwise you are a global corporation, probably have people all over the world?
Absolutely, yes. Yeah, we have manufacturing sites in several different countries and also sales offices and technical support offices that cover the entire planet.
And how many people does Rogers Corporation have?
You know, I might have to ask Mahyar that one, but I think we're around 3,500 if I'm not mistaken. It's roughly around there.
Yeah.
Okay, and what new technology trends are you seeing in your markets, and how is Rogers involved?
Right. Yeah, actually, there's been a lot. And of course, 5G, that was starting to be developed a few years ago. We were heavily involved with that. So we had materials involved in the development, and actually, we modified one of our materials. I'd have to say we optimized it for some of the technology demands that we've seen with 5G. So we've been very closely involved with 5G, and now that that's ramping up into high volume production, of course, we're also very involved with supplying materials for that. But we were right there at the very beginning with the initial development stages, and that was actually pretty fun. And also we got to learn a lot more about our materials in different applications. And then aerospace and defense, we've been working there for a number of years, and there's just so many different applications within that industry. It's hard to really pinpoint one. High-speed digital, we've worked with a good amount over the years, and from my experience, I've seen a lot of ATE type of testing, which is really a high demanding type of high-speed digital. But since these high digital speeds are becoming faster and faster, we've been seeing more and more companies come to us needing the expertise that we have for materials that can operate at very high frequencies, which also does have a relationship to high-speed digital. And then probably the most recent things for really big differences in technology, I'd have to say, was the mmWave push in a lot of different areas. And over the last 5 or 6 years, we've been working a lot with automotive radar at 77 gigahertz. And from that, we've also learned a lot about our materials that in the past we knew in theory, but you really never know until you start ramping up into high volume production. And now we understand our material properties extremely well, along with printed circuit board fabrication influences and other things, because we do have a group all around the world that does support the circuit fabricators and also another group that supports the designer. So for trends, I would have to say mmWave is really the thing that we've seen a lot over the last few years. I think it's probably because a lot of the chip manufacturers are able to now deal with these higher frequencies, which basically pushes the technology to the printed circuit board suppliers and ultimately to us. So that's kind of a quick overview of the things I've seen.
Okay, and what makes Rogers Corporation unique and differentiated in this space?
Yeah, this is, it's something we really just have a long history with, of course. Our high frequency materials, we started working with those, well, if I'm not mistaken, back in the late 40s, early 50s. And we were right there as microwave technology was being developed, radar technology, things like that for the military. But because of that, we have a very long history of understanding how to develop materials for specific applications and specific needs. Sometimes that's frequency related, sometimes it's power related, sometimes thermal management. There's just a lot of different things. But we have such a diverse, strong history and background of supporting these different high frequency applications that our materials really are very well defined and very well controlled as we make them in our manufacturing sites.
Yeah, I think you might have already answered this question, but let me ask you this anyway.
Sure.
So there has been a lot of discussion recently about the merging of requirements for very high-speed digital and high-frequency RF technologies, such as designs operating at millimeter wave frequencies, as you had said.
Sure.
So do you see the same trends, and can you comment on this?
Yeah, certainly. The millimeter wave technology, as I was talking about for automotive radar at 77 gigahertz, that's been developing rapidly over the last several years. And now I'd have to say it's kind of at the point where it's very, very well understood, but there are a lot of different nuances that has to be well understood. So we've got to work very closely. We have worked very closely with some of the top designers with these automotive radars at 77 gigahertz, and we've got a very good understanding how our materials work at these high frequencies, and also how wave behavior is, different resonances that you can run into, glass weave effect, just a variety of things. Now that's related to millimeter wave, and what we found though is that the high-speed digital, as they're getting into higher frequency, they have a relation to high frequency RF. And what I mean by that is the digital pulses are actually made up of different analog or RF frequencies, usually a harmonic and several, or usually the fundamental and several harmonics. And at lower speeds, digital speeds, then the frequency is also lower, which means some of these RF properties are less important. But as you get to these much higher speeds, then you're actually using RF components that are much higher frequency, and then a lot of the RF properties need to be very well understood and captured in high-speed digital design. And one thing I'll mention real quick is a good example would be some of the digital formats like NRZ or PAM2. They basically use a harmonic frequency that is about half the digital rate, if you want to look at it that way. And as you get to higher and higher digital frequencies, of course, higher harmonics, and in general, you have more issues with that. However, one of the new digital formats that's been used and is going to be used a lot more in the future, I think, is PAM4. And PAM4 basically cuts that fundamental frequency in half, which is a good thing. But PAM4 actually has multiple levels of digital data. And because of that, it's extremely critical to understand amplitude. And amplitude in an eye diagram is very much related to insertion loss. And at very high frequencies, of course, as you go up in frequency, you get more losses, which will affect the amplitude. So having a high-speed digital using PAM4 becomes really critical in understanding insertion loss and also some of the wave behaviors that happens at these very high millimeter wave frequencies. So I know this is rather wordy, but long story made short, just from our experience of dealing with millimeter wave, we've got a really good understanding of some of the needs for the extremely high-speed digital at 28 gigabits per second, 56, and even 112 gigabits per second. And we have done testing in those different speeds and also up to 110 gigahertz for RF. So I think we have a pretty good understanding of that, but it does help us really see that trend that's the blending of the technologies. It's very interesting, and I'm sure it's going to continue for the next many years.
Yeah, pretty awesome. So can you also tell us about the new materials Roger says commercialized recently for these high-end applications?
Sure, I'll pick up on that one, Sanjay. So, historically, in the high-speed digital space, we've had some of our legacy RF materials used in some of these high-speed digital applications, such as our RO4000 series materials. Where we decided to focus as we see this kind of emerging high-end requirement for high-speed digital as the 112 gigabit PAM4 type infrastructure is starting to roll out, we really wanted to develop a material system specific for that industry, that high-performance requirement. So we looked at our core competency of making ultra low loss, extremely low loss resin systems. And we developed from that our, our core competency in making PTFE technology and PTFE materials. So we looked at that and we developed the extreme speed RO1200 laminate family. So this is a glass reinforced filled PTFE system for anywhere from 3 mils to 10 mils in thickness. So we cover the range of thicknesses in 1 mil increments that are, it's one of the requirements for the high layer count, high speed digital designs versus typical RF designs that were lower layer count, thicker dielectric layers. So with the RO1200, then we developed a complementary bond ply, a bonding material, which we commercialized this year, and which is the RO1200 bond ply. We commercialized that in March of this year. And together, the RO1200 or extreme speed RO1200 system really is the pinnacle of what can be done in terms of performance on a copper clad laminate system. So we're talking strip line insertion loss of less than 0.7 dB per inch at 28 gigahertz, which is the Nyquist frequency for 112 gigabit PAM4. So that is really the ultimate. If you're looking for the lowest loss system, we have the RO1200 family. But as in these typical designs that are sometimes, up to 20, 30, 40 layers, you don't need to have the high performance material in all of those layers. So hybridization is very common in this industry. So we wanted to kind of build out that portfolio of materials. So at the high end, if you need the lowest loss, you can have the RO1200 family, both laminate and bond ply, to make your strip line circuits. Just in September of this year, we introduced a new thermosetting bond ply, which is the SpeedWave. We call it SpeedWave 300P. This is a high-speed digital 3DK DF at 10 gigahertz bonding material that's complementary with the RO1200 laminate as well. So here we have 11 different glass and resin combinations to really give the designer flexibility in their copper fill requirements for these multi-layer designs. And excellent electrical performance, especially when paired with the RO1200 laminate. And then of course, on the RO4000 family that's historically been used for high-speed digital application, we've even expanded that portfolio as well. So we have the RO4835T laminate and RO4450T laminate. And those of you that are familiar with the RO4000 series, we've always been limited in the range of thicknesses, typically thicker dielectric layers for, again, RF type applications. So now we've filled out the range of thin offerings on that RO4000 family. So you get all the benefit of performance and reliability that RO4000 is known for, but now you're expanding it further with offering thinner layers, again, that are optimized for these high-speed digital designs. So we've really rounded out the portfolio to meet all the requirements for the emerging high-speed digital market that John was talking about.
Now, you did quite a lot of very unique and innovative material designs here. Are these protected by any trademarks or patents, or are there other companies doing the same things as what you're doing?
Yeah, so there is some IP protection around some of our unique resin systems, but there's also a lot of trade secret and know-how in terms of the developing. Historically, as I talk about the RO1200 family, historically, when you talk to a customer that's maybe unfamiliar with our offerings, they hear about a PTFE material and they think very difficult to fabricate, very expensive, typically used in aerospace defense or high reliability applications. But we've really focused on the manufacturing part of it. So to try to take cost out of the manufacturing and make it suitable for a high volume manufacturing process so we can bring the cost down. And make it available for the more commercial market as opposed to the more niche kind of aerospace defense market. So those are kind of the things that we've done to that makes it unique for Rogers.
Okay, and what is the best way for people to find out more about Rogers Corporation on the internet?
So John, maybe you can talk about our technical support hub and.
Oh yeah, be happy to. Yeah, so we have a technical support hub we're really proud of. We have a lot of information in there. You can sign up for free, of course, and from there you can have access to quite a variety of papers that we presented at trade shows, which are usually pretty detailed. And then we also have shorter videos, sometimes maybe 5 or 10 minutes long, that gives a quick introduction to different technologies. And we have probably 50 or 60 of those at this point. And we're adding just about, I wouldn't say every day, but we're adding pretty often. We also have the ability to contact a representative in your area. And so anyway, we also have software as well that is free for download, or you can actually run the software on our website. And that software can help you do impedance modeling, loss modeling, things like that. It's relatively simple, but it's usually pretty accurate. So anyway, our technology support hub would be the best way to contact us and also look at a lot of the technical resources that we have available.
Well, thank you so much, John and Mahyar, for taking time to record this interview. Have a great day and stay safe.
Thank you. You too. Thanks, Sanjay.
Thank you. Goodbye.
This is Sanjay Gangal from EDACafe.